from Unit 8 from last year. Remember that unit that nobody remembers anything about? One. So we're going to do a little bit of review, then we'll carry on. Rationals and radicals. Yeah, Unit 8. Let's just go back to last unit. Tell me what you know about a variable or a coefficient in front of a function. If it's sinusoidal, yes. Oh my God, you have a test on this tomorrow. Vertical, yes. Yes. Whew. Tell me about a coefficient inside the brackets or under the radical. Oh, now we're on, yes. Yes. What makes a radical function radical? The thingy. Yes, more specific. The thingy being the square root. That's what makes a radical equation a radical equation. So we did these as base graphs in Unit 3. All we're going to do is look at them from a different way. We're now going to do them as a transformation instead of as the base graph. So I'm going to give you a different base graph, then one of the transformations is going to be to take the square root of that graph. So we're going to start with linear, which was the easiest first functions you learned in grade 10. We're going to sketch the linear function, then we're going to take the square root, then we're going to compare the domain and range. How do you graph a line? Mx plus b, yes. What do we do with mx plus b?
Well, the y, or the b.
Yes.
You put a point at the b, so the y, on the y-axis.
And how do we define b? What's its vocabulary word?
No, when it crosses the y-axis.
Which is the y-intercept. And then?
And then -2 is your rise over rise.
Correct.
Go down 2 over 1. And then the opposite up.
Just a heads up for the test tomorrow, any kind of straight line, so an absolute value graph or a linear graph, needs to be with a ruler. You have access, so don't be barbarians. Don't just draw jagged lines. We used mx plus b. So we counted down 2 over 1 from our 1. That's what Noah just explained to me for the last 3 minutes, was how to graph the line. Go to red pen, because this is going to be our last graph. Again, difference now is this is not the base graph, it's one of our transformations. So what we're going to do is one by one, we're going to take the y values and take the square root. So I'm going to start at where y equals 9. Okay? What is the square root of 9? So this number is going to drop all the way down to 3. So the x didn't change, only the y changed. I'm not going to use 8, I'm not going to use 7, I'm not going to use 6. Why am I skipping these numbers? Because I want perfect squares. So what's the next y value I'm going to use? Okay, so look where y equals 4. Okay, take the square root of 4. 2. X value didn't change. All I did was drop the y value down to 2. What's the next good number that I'm going to use? So I used 9, I used 4. 1, okay, here's where y equals 1. Square root of 1. Oh, okay, so that point doesn't change. What's another great number to use? 0. 0 is a great number. What's the square root of 0? Okay, so that one doesn't change either. What about -1? Square root of -1. Doesn't exist. Why? Because it's negative. So can we find a number times itself that gives us -1? Okay. What about -4? Would be the next perfect square. Okay, so -4, can I take the square root? -9. So can I take the square root of anywhere under this? No. So here's our square root graph. And we already know what the base shape should look like. It's our swoop. This one happens to be a swoop to the left. Only difference from last unit is we started with the square root, then did transformations. This time I'm giving you a different base graph, and this is a transformation, and the transformation is take the square root. So if you don't want to do it the method I just did, which was point by point,
Wait, but it says
domain and range. Thanks, Noah. I'm going to color code, so domain and range of my original, domain and range of my new graph. It's always easy when it's a linear function. What's the domain of any linear function? XER, or negative infinity to infinity. What's the range of any linear function? Or negative, or YER, or negative infinity to infinity. So they want us just to compare what's going to happen. Are these going to change because we did the square root? Are they going to stay the same? What's going to happen? So domain, look to the left, look to the right. What's the lowest value? What's the highest value? Negative half to negative infinity? No. Negative infinity to a half. And if I want to match this notation, okay, what about the range? Look down and look up. Offers y is greater than or equal to 0. Other notation would be 0 to infinity. So what happened to both our domain and range? They changed. Both of them are going to change because of the square root. Okay. So if you don't want to do it point by point and you want kind of a better method to do it, we're going to talk about some properties of the two functions. Zero and 1 are really special points in terms of our square root graph. So if 0 and 1 are in the range of y equal to f of x, then points with these coordinates will lie on both graphs. Why? Why do these points not change? Yeah, they're the only two numbers that are their own square root. So square root of 1 is, and square root of 0 is. Those are the only two numbers that are their own square roots. We call these invariant points. Invariant points. What does invariant mean? Well, what does to vary mean? You change something, so invariant means non-changing. Okay, so I'm just going to draw any line. I don't know, what am I going to draw? I'm going to put a dot at 3 and -3. Why? I don't know, just pick 2 points. So what invariant points means is if I'm going to do the square root of this, wherever y equals 1 and wherever y equals 0, those points are going to be exactly the same. They are not going to change. They are invariant, non-changing. So I know my square root would swoop this way. The second thing we know is that where the graph of f of x lies below the x-axis, so I'm going to flip back, you stay. That's these points we talked about here. If they lie below the x-axis, what do we know about them for our square root graph? They're non-existent, they don't exist. They do not exist. So if we use the same line as above for no particular reason, apparently I really like 3s. What this point tells us is any of these points below the x-axis are no longer going to exist once we do the square root. So they're still in the original graph, but when we go to do the root, they disappear. They don't exist. Impossible. So instead of going point by point and doing the square root, we're going to use these two facts, and you're going to love these graphs because they're so stinking easy. Step number 1, mark the invariant point. So go wherever y equals 0. Wherever it cuts the graph, put a point. Mark the invariant points. Go up to y equal to 1. Wherever it crosses the graph, put a point. Step number 2, you're going to completely ignore anything under the x-axis. So all of this will be gone. If you want to cross it out, great. If you don't need to do that, don't. It's totally up to you. I like to cross it out to remind myself that we don't need to look at it. It doesn't exist on our new graph. The third is we just need to decide which way it swoops. Well, that comes from the 2 points and the direction of the line. If it's got to go through these 2 points, it has to swoop what way? To the left. So we go from point 1 to point 2 and swoop. Done. There's a radical graph.
Once you have those 2 points and do a sweep, exercise.
So I'm going to repeat the steps in case you're a method person and you want it down in words. Step number 1 is mark the invariant points. Mark the invariant points. And that's where x equals 0 and, or sorry, y equals 0 and y equals 1. Step number 2, ignore all points under the x-axis. Ignore all points under the x-axis. Patrick, put it away. Step number 3, decide the direction of the swoop. Decide the direction of the swoop. How do you do that? Well, why did the little example up here swoop to the right, but this one we just said swoop to the left? What's the difference between these 2 lines? So what do we call the characteristic of this one? What makes the tilt of the line?
Well, whichever the way the tilt is going, you go to swoop.
And what decides the tilt? What is negative or positive?
The slope.
The slope. So a positive slope means we swoop to the right. Repeat that, positive slope, swoop to the right. And the other one, the example down here, negative slope, swoop to the left. Turn to someone in front, behind, beside you, and do the domain and range together. Offer for the domain. This is what I kind of heard mumbled. Just not or equal to. We like that better. What's the other notation? Negative infinity to. Are we happy with 0.5? Okay. Range? Or? Got it. Step number 1. The invariant points. Where are the invariant points? Okay, so go where y equals 0, which will always be the x-intercept, by the way. Second one is at y equal to 1. Ignore everything underneath. Swoop to the right, y? Positive slope. Done! Square root. Love it.
It's like the easiest unit.
Well, you're not going to like the second half. Because you didn't like it last year in grade 11. You're not going to like it now. Okay, well, that's linear. That's great. But let's do some quadratics. Yay! Again, why do I have a hate on for domain and range? Dahlia? Domain?
I don't know what number that is.
It's like 3/4.
3/4?
Less than 3/4. It's like
2/3? We're happy with 2/3?
I guess so.
Kate? They rejected 0.75. Well, then you use it. The range? Are you seeing a theme with the range? Now let's go on to quadratics. Oh, and then cubics after, but shh, let's not talk about it. It's too exciting. Okay, what are the 3 pieces of information we need to graph a cube or quadratic?
Vertex, width, and direction.
Okay, give me the vertex.
0 and
Direction. Width.
1 through 5.
So tell me how to count.
1 up 1. 1 on 3. 1 on 5. And then the other side. 1 on 1. 1 on 3. 1 on 5.
That was great instructions. Steps are not going to change, still the same 3 steps. So what was the first step?
0 is
Okay. Ooh, how many x-intercepts do we have? Ooh, kind of cool. Okay, go up to where y equals 1. Ooh, how many points do we have here at y equal to 1? Ooh, kind of cool. We're only on step 1. What is step 2?
slope direction.
Ignore it. Ignore anything underneath the x-axis. Cease to exist. It's dead to us. Well, now if we just look at this half, swoop to the left or swoop to the right?
To the left.
How do you know?
Because the second dot is after the first dot.
The second dot's after the first or further to the left. If we think of this like a line, would this have a negative slope or a positive slope? There's our swoop to the left. What's going to happen on the other side? Double swoop. I got the domain and ranges back this time. What do we do for domain? There's 2 pieces. Okay, well, let's just look at the left first so I won't get scared. So I had an offer of x less than or equal to -2. Not hearing any confirmation. Okay. Now what if I just look at the right? Offer x is greater than or equal to 2. Now how do I mathematically say both of these? There's a mathematical symbol. That would be in between, and it's not in between.
Could you say everything? Oh, -2. Everything but the middle. Everything but the middle somehow.
You could. I'm trying to think if we would do that. No, we just wouldn't. You could, but we don't. Symbol looks like this. Ooh, what is that? It's kind of a U. It doesn't have a tail on it. Its official name is union. And what does union mean? It means and. So what that is saying mathematically without words is that x is less than or equal to -2, and it's greater than or equal to 2. Exactly the same symbol in the middle. So you can still use your brackets, you're still going to use the union in the middle. Okay, what about the range? So left-hand side first. That sounds confirmed since I heard it twice. Okay, what about the right-hand side? Same. So do I need to write it again? Nope, so just one piece for the range. That's not bad. Double swoop. Well, we're going to do a cubic eventually. We're not there yet. What kind of graph? A parabola graph, yes. How many, or what piece of information do we need to draw a parabola? What's the vertex? What's the direction? What's the width? Okay, tell me how to count. Continue how? Oh, no, we don't want to ignore the bottom yet. Don't get ahead of yourself. Okay, I drawed it. Ooh. Invariant points. What's an invariant point? Why? Their own square roots. So we got two x-intercepts, two values where y equals 1. Now our little swoop rule fails us because it's going this way, but what do I do? Just do it. How? I don't understand. Can this part swoop to the left and still go through those 2 points? No. Could this swoop to the right? No. So it tells us this one's going to be something a little bit different. I'm going to take the max because it's a really nice, clean point. It happens to be a perfect square. And don't forget our function is square rooting. So what's the square root of the max? 3. So let's draw that point in. Now is it clearer what the graph looks like? Just a little bump. Although in Manitoba, that's like a mountain. Okay, so whenever you have a down parabola, you're going to get bump. When you have an up parabola, it's going to be double swoop. 2 swoops of raisins. Domain. Domain. Does it actually go through to a -2? It's close to -2, but it's not exactly on -2. How can we find those points exactly? Because we have the equation, so we can't just guess when we have an equation. Oh, we could do what now? Yeah, we could do what? We could. That's not going to help us find the x-intercepts, though. Talia? Okay, so how many ways are there to solve a quadratic equation?
5.
What are the 5 ways? Square root. Which method would you like to use here? Grouping method is a factoring method.
No, not even. Maybe. Quad, no. Quadratic, please.
We should spend 3 units on this in grade 11. How about square root method, because it's the easiest? How about we review that? How do we get rid of the 9? How do we get rid of the negative 2?
Divided by negative.
So we're down to x squared equals. Ah, you're ahead of me. Shh. Square root, or x squared equals. 9 over 2. We don't use decimals. How do we get rid of a squared? Oh, and what has to go in front of you, in front of it, that half of you forgot on test 1 and test 2? Why is that so important here? Because how many x-intercepts are there? 2 x-intercepts. Okay, what do we do when we have a crazy square root? So you evaluate what you can, you leave what you can't. So can we take the square root of 9? Can we take the square root of 2? So I'm just going to leave it. Rationalizing, don't forget, is completely up to you. If you want to, great. On the exam, you don't need to. So which value is the first x-intercept, or the one on the left? It's like a lot of words at one time. And what is the one that's on the right? Okay, so make yourself a note. When they give you the equation, you can't guess at the x-intercepts. So you can't guess, say, oh, it's 2.2, right? No, you can find them exactly. Okay, so when the equation is given, find the x-intercepts. Okay, how do we say between? And if you want to use the other notation? And both of them would be square brackets. The range. Show me your thumb. How are we feeling so far in rational or radicals? I get it. I kind of get it. Just in general, the lines so far, the invariant points. Okay, one more quadratic, then we'll do a cubic. What are the 3 pieces of information we need to draw a quadratic equation?
Wait, say that again?
What are the 3 pieces of information we need to draw a quadratic equation? Okay, vertex. Oh. Okay. Oh, factoring is only going to get us the intercepts. It's not going to get us the vertex. We need to do something else that we might have practiced 500 times last year. And what's that called? What's that process called? I only said it like 500 times.
Today?
No, last year in 3 different units.
The vertex formula.
No, it's called, it rhymes with completing the square. Completing the square, yay, let's review. How do we complete the square?
You divide it by 2.
There's a lot going on.
X plus 2, X minus.
What have I not put down right now?
You have to divide the plus 2.
Where do I put the plus 2?
Oh, on the other side.
I just put it over to the side, I ignore it for now. Then we got to fill in a space, and we got to fill in a space. Kind of coming back. How do we fill in the first space?
The 4 by 4 divided by 2 squared.
Okay.
So 4.
Okay, so you might want to make a note where that 4 came from. So it's middle divided by 2 and then squared. Middle divided by 2 squared. And what goes in the second space?
Minus 4.
Why?
Because equal out the equation.
Yep, to balance the equation.
Would we have to put a bracket before the 2?
Up to you, you don't have to, but. Then I'm going to group the first 3 and group the last 3. The first 3 are going to factor into a binomial squared. Where did the 2 come from? And how did you get 2 out of them?
X plus 2 squared equals x squared plus 4x plus 4.
So it's middle divided by 2 is where this number comes from. Then we just combine the last 2. Yeah, we should practice it in 3 units in grade 11. Then you'll know it by grade 12. It'll be really easy. What is the vertex? What is the direction? How am I going to count? Last year, I did the same thing where I use a rhyming word to get you to say what I want you to say, like I'm bleeding the square, except I was trying to get them to say the word direction. So I said, rhymes with erection? Yes, yes, I did. Yes, I did. Step 1. Invariant points. So mark the 2 x-intercepts. Go up to 1, mark those 2 points. Now you already know because it's an up parabola, what is this going to look like? Double swoop. Ignore everything underneath. Swoop to the left, swoop to the right. Turn to someone in front, behind, or beside. Write the domain and range together. How many ways are there to solve a quadratic equation?
5.
Graphing, completing the square.
Square root.
I said that.
Which one would you like to do?
Square root.
I would also like to do square root. How do we get rid of the minus 2?
I had 2 on the other side. But you have to put all of this.
And where do we put it?
Behind the, like, after the half square root is
Before. It always goes before.
Doesn't matter.
It doesn't. It's just when you solve using quadratic formula, it's like this, so we like to keep it the same. Because this is your b plus or minus the square root of b squared minus 4ac. Okay, so which one is this guy on the left? How do we know that it's that one on the left? Because that's got to be a negative number. And on the right, it's got to be? Yes.
It's positive. Oh. They're both. No, square root 2.
Okay, domain.
X has to be less than or equal to -2 subtract square root 2.
And I'm going to do the other notation just because I haven't done one yet. And the other half of it?
What about the U?
Ooh, I was going to do it after, but yes. But don't say the word or, say the word
I said U. And
and.
X is greater than or equal to -2 plus square root 2.
And then we're so happy when we come to the range.
Why you are?
Ooh, no, no. Look down, look up.
No. No, is crazy. Oh, no. Oh. Oh, y has to be greater than or equal to.
Yes. Whew.
That's what I had.
Cubic? Cubic. Cubic. Step one.
The
Thank you, Brian. Invariant points. So go to where the x-axis is. Ooh, look, look. There's 3 of them. And? Step 2.
erase the bottom.
So first, let's just look at the left-hand side of this. So let's just look at this. We've done one that looks very similar to that. That would be like a down parabola. What do we know when we take the square root of a down parabola? It's a little bump. So we've got to figure out where the bump's going to be. Okay, so what's the y value right now at the max? About a quarter? Half? A third? A half? What can we agree on? Okay, what happens when you take the square root of a half? 1 over root 2. And 1 over root 2 is about how much? Okay, so we know that's root 2 on 2 from the unit circle. That's about how much? Pi and 4 would be the angle value on the unit circle, but nothing to do with this. Give me an estimation. 0.6 something?
Just over half.
Really, really close to the same.
So would you get mad at us if we just sort of
Nope.
the same?
Nope. Okay, now let's look at the right-hand side of it. Well, we've seen something like this before, because that's just like an up parabola. It's a swoop to the right. So this is just like a quadratic combo. Domain. Oh, you want it to be harder? Domain.
One of them.
Okay, well, let's do the little bump first.
1, 2, 0 to 1. Negative 1 to 0.
Okay. Now let's look at the swoop.
Oh,
How do I say and? And what does the U stand for? But what's its name? Union. Okay, the range, let's do the bump first. Okay, we'll take a look at the swoop. Is it going to encompass the range of the bump? Yes, because this is from 0 to something something, but this one's from 0 to. So do we need to put the range of the bump? No, because it's going to incorporate in this one. It's 0 to infinity, so that's going to take care of the little bump. Little summary for the left brainers. We like summaries. I'm just drawing 4 little sets of axes. Positive line, I'm not putting it anywhere particular. Just drawing a positive line. And then a negative line. And then an up parabola and a down parabola. Positive line. What does a square root look like? Swoop to the right. Negative line or negative slope. Up parabola. Down parabola. And then a cubic's just a combination of those. So you've got some choices now. You've got about 20 minutes.